So the problem we have is if the radius of a small circle lowercase r is 1, so notice we have 6 small blue circles, each of those with a radius of 1, lowercase r, and a diameter lowercase d. What is a diameter of a large circle, uppercase D? So we have one large circle with a diameter d and a radius of uppercase R. So this problem was brought to me by one of my grade 5 students, and the solution is quite interesting because it relies on relatively simple geometric concepts, even if those are a bit advanced for the grade 5 level. I thought I'd share it today and give you the solution. So before I do that, you're welcome to pause the video and try it yourself. And without further delay, let's get right into it. So the geometric concepts that are required to solve this problem are the area of circles. So the area of a circle, as we know, is pi times radius squared, or just pi r squared. And we also need some knowledge of the Pythagorean theorem, which says c squared equals a squared plus b squared. Just as a quick reminder, we have a, b, c of our right angle triangle, and c squared equals a squared plus b squared. So c is just going to be root a squared plus b squared. Okay, again, concepts slightly advanced for grade 5 level, but let's see how we can proceed. So given the sketch here, one thing we notice is that we're actually forming a right angle triangle somewhere, so it gives us a little bit of a hint how we can use the Pythagorean theorem. So what I'm going to do is I'm going to create my right angle triangle. Like so. Pretend it's not quite 90 degrees, but let's pretend it is for now. So I have a base, right? A height b, and a hypotenuse c. Okay, so the base is simply 2r, right? I have r and r, right? Radius of my small blue circles, and the height is also just going to be r, right? And so I have my my base and height in terms of my dimensions of my small circles. And the hypotenuse for now I'll call c, because that hypotenuse isn't quite anything yet, right? It's not the full radius of the large circle, it's not twice the radius of a small circle. So let's figure out what that c value is and why I haven't extended the full length. So c squared equals a squared plus b squared, right? So c equals square root a squared plus b squared. Excuse my messy handwriting. So let's plug in those values. C is equal to square root 2r squared plus r squared. So 2r squared is going to be equal to 4r squared, and r squared is simply just going to be r squared. So c is simply going to be square root of 5r squared. And we can simplify that slightly to root 5 times r. So we're almost there. Like I said, that c value isn't quite anything yet. But to get the full length, right, the full r, to solve the problem, we need to find the relationship between the radius of the small circle, which we're given, and the diameter or the radius of the large circle. Either one is going to net us the final answer. So that r, right, this r, is going to be complete if I extend that c a little bit more to the outer edge of the circle, right? And this little piece I've added on is again just going to be r. So the full r is going to equal c plus r. So my full radii is going to be c plus r. And we just defined that c value in terms of r, right? In terms of lowercase r. Root 5 plus r. So what I can do is factor out the, root 5r plus r. I can factor out the r value. So I have root 5 plus 1 times r. Small interesting observation, this root 5 plus 1 is an appearance of the golden ratio, right? Which is root 5 plus 1 over 2, which appears multiple times in geometry and math problems. Okay, so we've actually figured out the radius of the large circle already, right? Because r is simply 1. So let's take our working space over to the left. And we know, because small r, lowercase r is simply 1, that uppercase r, or the radius of the large circle, is going to be root 5 plus 1. We also know that the diameter is twice the radius. So our final answer is going to be the diameter is twice root 5 plus 1. And we're done. I hope you enjoyed the video, and I look forward to presenting more of these problems to you in the future. See you next time.